Hello students, today we are going to do an experiment of digital electronics, which is to study all logic gates, that is AND or NOT, NOR, NAND and XOR, and verify their truth tables. For this experiment we need logic trainer kit, logic gate ICs and connecting wires. Basically we gets a box in lab which includes logic gates, and with that we use to verify the logic gates. First I want to show you the all logic gates, their symbol, their logic operation, and we will feel the outputs as we will get from the logic gates. See, this one is AND gate and this is its symbol. The logic operation is this thing, means this symbol gives us that if any of these two will be 0, will lead output to be 0, and in case of both 0 will get output 0. It is like just multiplication. And OR gate, the next one is OR gate. The symbol is this one, and it is also a two-terminal input gate, and it is its logic operation is y equal to a plus b. Y is output, a and b are inputs. In A and B will be the inputs. In case any of the input will be high, then the output will also be high. And in case of both will be high, output in that case also be high. And the next one is NOT gate. NOT gate is just a single input terminal gate which just invert the input. Means if you are putting here in the input high, you will get low, and in case of low you will get high. So we will check that with our apparatus, that whether it is coming or not. And the next one is NAND gate. It is nothing but just one NOT gate attached to the AND gate. Means output of an AND gate is just input of a NOT gate. And the next one is NOR gate, similar, a NOT gate attached to an OR gate. And the next one is exclusively OR gate. We got in that one that in case of OR gate, if any of the input will be high, we will get output as high. But this is special case where when both of the output will be high, will leads to the output to be low. But it was not same in case of OR gate. In case of OR gate, when both were high, output was high. These are all the gates we need to verify their truth table. So now we will go to the apparatus where we will show whether the outputs are coming as we are expecting or not. This is our apparatus for this experiment. We need some connecting wires to connect, and this is the box where there are many, you can see many ICs. See, there are 6 ICs to realize different gates. You can see different ICs are responsible for different gates. This one is IC 7408, this one is 7432, and so on. There are many ICs which are taking for different gates. What all we need is input and gate and output, some indicator for the output. In case of input, we have four ports. Two are high. High means, see, this one is high and the first one is high, and two are low. This one is low and this one is low. It means, like, if you want to take two inputs to be low, we will use these two ports. If you want two inputs to be high, we will use these two ports, or in case of one high and one low, we will use this one and this one. And this is for input, and output. For output, we have one LED which will help us to know whether the output is high or not. If it is not high, then it is obviously low. So now we will perform the experiment. At first, we will do for AND gate. In the first one, we will keep both the input of AND gate low. So this is first input of AND gate, and we will put it in low, and the second input, which is B, will keep it low. Now to get the output, we need to plug this output to the output indicator. Okay, now we'll turn it on. We turn this on with both the input 0. We are getting output as low, so we'll note that now. Second one, we'll turn it off. We'll make one high and one low. We will do B high. We are doing B to be high. Okay, now we'll check. We are getting the output as 0, so we'll note that also. We'll do A as high but B as low. A we are doing high, we kept A high but B low. So in this case, the output is, see, this light is not glowing, so this is low. In case of A high B low, we are getting low output. And the last case, we'll keep both A and B as high. In that case, see, we are getting high output. And which is matching with AND gate. Now we'll do for OR gate. Similarly, for OR gate, we'll connect A and B with the input. We are keeping both low in first case. A and B, see, both are low, and we are connecting the output to the output indicator, and we are turning it on. In this very case, we are getting low output. So we are noting this down as low, and the second case, we'll keep B as high, but one end as high and one end low, so we are keeping B high and is low. In this case we are getting output as high, so we will note that also. When B is high, A is low, we are getting high output. And the third case, where A will be high but B will keep as low. In this case also we are getting high output, so we will note that also as high. And the last case, when both the inputs will be high, in that case the output is high, means in this case also the output is high. So only the case where both the inputs were 0, the output was 0. Other things, in the other cases, the output we are getting is high. Now we will do the verification of truth table for NOT gate. So we need to give it some input and we need to check the output whether it is low or high. So first we are keeping it as low, then we are turning it on. So in case of low we are getting high, so we will note that. And now we'll change the input to high and the output we will get is 0, means low, so we will note this also. Now we'll go further for XOR gate. For XOR gate we'll give it two inputs A and B, and output will connect with output indicator. Now in the first case we'll keep both the input as 0. See, we kept it as 0, and output we are getting 0. This is output indicator and we are getting it low, so it is 0. Now we'll change B to 1 and A will be 0 only. So in this case, see, we are getting high output, so we'll note that as 1. Now we'll change A to high but B to low. In this case we are getting output as high, so we'll note this. And the last one, when both the inputs high, we are getting it low. So we verified all the truth table of logic gates, and thank you for watching.